All right, we're going to go over example number 2 again. Excuse my puppies in the background. They're playing with the backyard dogs. All right, so we're going to first see if we can simplify, and because we have 3 terms in the denominator, we can see if we can find its factors. The numerator is already in its factored form, so that's x plus 2. And then we're going to do negative 10 over and then negative 3. So the factors will be 5 and 2, with 5 being the negative. So we're going to go x minus 5 and x plus 2. You notice we can cancel out that x plus 2. And remember, with anything cancels, then it's basically equal to 1. So my numerator is going to be 1, and my denominator is now going to be x minus 5. So this is the equation we're going to be using for, the expression we're going to be using for the rest of the graphing part. Because we were able to cancel x plus 2, your h tells us that we're going to set the canceled factors equal to 0. So my canceled factor was x plus 2, set that equal to 0, and we get x is negative 2. So in order for us to find out where that hole is going to be, we need to find out what the y value is, and we do that by entering it into the expression that we found here. So we've got 1 over, and instead of x, we're going to plug in negative 2. And 1 over negative 2 minus 5 is negative 1 over 7. So with that, negative 1 over 7 is approximately negative 0.14. So my point is at negative 2, negative 0.14. And that's my hole. So when we graph or draw our graph, we're going to basically jump over or skip that open circle. Let's go to the R. The R tells us that we are finding the roots, so we're going to set the numerator equal to 0. And again, we're going to be using this one. So our numerator is 1. We set that equal to 0, and 1 is not equal to 0. So that means that this has no root. We'll set the denominator equal to 0. So my denominator is x minus 5. We're going to set that equal to 0. And when we solve, we get x is equal to positive 5. They don't lie when they say beagles are loud. We're both beagles. All right, so then that's going to give us our vertical asymptote. So we're going to draw a vertical line through x equals to 5. Next, we're going to look at the end behavior. Now, the end behavior is where we look at whether they are balanced or they are bottom heavy. Now, remember, we're going to look at the exponent for each of the numerator and the denominator, or I'm sorry, the term with the highest exponent for each of the numerator and the denominator. So we have x minus 5. The denominator x has an exponent of 1, and because there's no variable in the numerator, that means that we have an x to the 0 power. So because the x in the denominator has a higher power, this means that it is bottom heavy. And because it is bottom heavy, we go back and we see anything that's bottom heavy, your horizontal asymptote will be at y is equal to 0. So that's where we're going to draw our horizontal asymptote. Then we're going to look for our y-intercepts. That's what the y stands for. We're going to plug in 0 for y. I'm sorry, 0 for x. So instead of x, we're going to put 0. And we end up with negative 1 over 5. So that's going to be my y-intercept. That's about negative 0.20. So on my y-axis, we're going to plot at negative 0.20. Now for the test points, we want to be strategic. So we want to look at the vertical asymptote, and we're going to look at the two x values to the left of it. Now the reason for that is because we want to see where the curve is, and wherever the curve is, we'll be able to draw or sketch the rest of my. So we're going to solve when x is equal to 3 and when x is equal to 4. Now we're going to use the same equation, but instead of x, we're plugging in 3 for this one. And over here, instead of x, we're going to plug in 4. And remember, we're still using the same equation that we simplified up here, because that's going to give us our y value. This is negative 2, so this point is going to be 3, negative 0.5. Here, this is 1, negative 1, negative 1. So this point, so for those points, 3, negative 0.5, and 4, negative 1. And here you can see that there's somewhat like a curve that we can use to guide. So let's go ahead and draw it. And remember, when you hit a hole, you're going to jump over it, and then you're just going to continue your graph getting closer to the asymptote, but not touching it. And the same thing for this direction. So now we have the left side of this graph. Now we're going to use the points on the right side to see where those points are on the graph. So we're going to test x is 6 and x is 7. Minus 5, 1 over 7 minus 5. 1 over 1. So this point is at 6, 1. 1 over 2. So this point is at 7. And then positive 0.5. 6, 1. And 7.5. And we can more or less guess where, sketch the graph from here. So we know it's going to curve this way, getting close to the asymptote. And then the same thing to this side, getting close to the asymptote. Now for our domain, remember we talked about it'll be all real numbers except where my asymptote is. My asymptote is at 5. And it's also not going to include the x value where my hole is. So that x value is negative 2. And for the range, we've got all real numbers except where my asymptote is, and my asymptote is at 0. So it cannot include any y values at 0, or where my hole is. And my hole is at negative 0.14. So it's all of the y values except those two. So for this one, I'm going to use the fraction, because that negative 0.14 was more of an estimate, so we can graph it. So here we're just going to put negative 1 over 7. All right, let's go ahead and go over example